Hello, this is Charlene. We're going to be talking about expanding and condensing log functions. There are three primary log rules which govern how we expand condensed log functions. These log rules are the product rule, the quotient rule, and the power rule. In your textbooks, they will look like this. Log base b of m times n is equal to log base b of m plus log base b of n. And so basically what that tells us is that if we have a product, which is a multiplication, we are allowed to separate it into two addition parts. So this is kind of like order of operations for log functions. Okay, so the next one is going to be our quotient rule. Our quotient rule says that if we have a quotient, which is the division of two numbers or two expressions, that we are allowed to change it from division to a subtraction of those two terms. So that is the quotient rule. And the third one says that we have log base b of m to a power, and it says p times log base b of m. So essentially the power rule is telling us that if we have something to our power, we are allowed to actually bring that power down in front of that term. And so x squared, if that were the term, would become 2x. In this case, a lot of times we're going to have logs, though. The x would actually represent a log. So if we have log of 4x to the second power, well, we could bring that 2 down in front of the log. And so, like I said, this is like order of operations for log functions. So I would bring that down, and it would become 2 times the log of 4x. So I'm allowed to do that using this power rule. Okay, let's go see what kind of problem we have to work on. Okay, so this says to use the properties of logarithms. Like I said, log rules, properties of logarithms, those are kind of interchangeable. And we're going to expand. Okay, so we're expanding it, which means we are making it bigger, or we're going to pull it apart into its pieces. Okay, so we have to look at what they gave us. They gave us log base b of xy to the 8th power divided by z to the 4th power. So we need to make sure that we are taking care of the outer functions first. So we would not undo this multiplication first. Anytime you have a term or an expression on top of a fraction bar, it's kind of stuck together. You kind of think of it as having parentheses around it. You cannot take it apart until you undo the division, the fraction bar. So you have to get rid of that fraction bar first. So that fraction bar, what does it represent? Does it represent multiplication, a product? Does it represent a quotient, which is division, or does it represent power? Well, it represents division, right? It is a quotient. Anytime we have a fraction bar, that is a division, which the name of a division transaction in math is called a quotient. So that means we are going to use the quotient rule. The quotient rule says that if I have a division of two terms or expressions, I can separate them and turn them into a subtraction. So I can separate them. So I'm going to do log base b, and your numerator will come first. So x, y to the 8th, that's my numerator, minus log base b of the denominator, z to the 4th. So that is using the quotient rule. I'm allowed to change that quotient into a subtraction transaction. Okay, so the next thing that we're going to do, let me pull this up just a little bit. There we go. Now we're going to say, okay, what do we have now? Now that we've used the quotient rule, we've changed it into a subtraction. Now we can look at this section right here. We're going to look at x times y to the 8th. Well, what is going on in between those? Well, it is multiplication, which means that I can now employ the product rule. The product rule says that if I've got a multiplication of two terms or expressions, I can separate them into addition. This is like I said, order of operations for logs. It's the log rules, it's the properties of logs that gives us these rules that allow us to expand or pull apart all the pieces of logs. Okay, so that means that we are going to change this part into an addition. We're going to say log base b of the first term, which is x, and we're going to add it to log base b of the second term that's being multiplied, y to the 8th. So y to the 8th. And then, of course, I still have log base b of z to the 4th. So now we look at where we are now. Well, I've already taken care of, I've used the quotient rule here. I've used the product rule here. So now I need to look, can I separate anything else? Okay, so here at the end, I do have a power. I have z to the power of 4. And like we said at the beginning of the video, that means that I am allowed to bring that 4 down in front. So I can rewrite this finally as log base b of x plus log base b of y to the 8th minus 4 times log base b, oops, b looks kind of funny there, base b of z. But I also have a power right here as well. So that means that I probably need to go ahead and move it down in front. So I'm going to move it down in front. And when I do that, I can just erase it there. I'm going to scoot all this over. So that's going to be plus 8 times log base b of y. So at this point, I have used the product rule, the quotient rule, and the power rule twice. I used the power rule right here. I used the power rule to bring this one down, and I also used the power rule to bring the 8 down. So that is my final expansion of this original log. So this was my original log, and I've now expanded it into these 3 terms. And like I said, this gives us an opportunity to solve things. When we use order of operations in Algebra 1, we're just using it to pull things apart, to simplify things, and it helps us to solve for things. And so these log rules are acting the same way that Algebra 1 order of operations rules act. It helps us to be able to move things around so that we can solve for answers. Our next problem says that we're going to use the properties of logarithms to condense the following expression into a single logarithm. So condensing it is to make it smaller. Right now it's kind of spread out, and we're going to condense it and make it smaller. So we need to look at what they've given us. They gave us 1/2 times this whole quantity of a log of an expression minus a log of a single variable. Okay, so we always want to look at the outer, what's going on the outside. So on the outside, we have this 1/2. So if we recognize that, we could recognize that it is a power. It is, and we're going to go backwards though, because we are condensing things. We're actually going backwards. So we're going to start here where the power is in front, and we're going to move backwards and bring it back up to the power position. So I'm going to take that 1/2, and it's going to move back into the power position. So I would rewrite that as the log base 7 of r minus 8 minus log base 7 of r, and that whole quantity is now being raised to the power of 1/2. Okay, so now we look at what we have at this point. We have log base 7 of r minus 8. Now, you might think, oh, well, there's a subtraction. Can I use the quotient rule? But no, we actually cannot use the quotient rule there because each one of these would need to have its log. I would have to have a log of the r, um, a log of the r minus a log of the 8 in order to employ the quotient rule. So we have to ignore that. That subtraction within that little expression does not qualify. Does not qualify for the quotient rule. But this right here, the quotient rule, which allows us to have a subtraction of two log terms and return it to a quotient, that can be employed by this right here. This is a log of something minus the log of something that is qualifies for the quotient rule. Okay, so that means that we can rewrite that as the log base 7 of the expression r minus 8 divided by the r. So does that make sense? I have a log of something minus the log of something, and I can take this, move it to the numerator. I can take this and move it to the denominator. So that's how I change that. But we can't forget that we still have everything raised to the 1/2 power right there. Okay, so technically we could probably leave it there if we wanted to. That is not necessarily an incorrect answer. Um, so that's an answer. But if you wanted to, we could actually distribute that 1/2 into the parentheses. If we wanted to, we could rewrite that as the log base 7 of r minus 8 to the 1/2 power. Oops, that looks kind of weird. 1/2 power divided by r to the 1/2 power. So either one of those would be an appropriate answer. We could leave it like this, or we could distribute that 1/2 into the parentheses as well. Okay, so hopefully that helps you get started understanding how to expand and condense logs using the log rules. And again, just to reiterate, this is like order of operations for logarithms. So have a great day, and we'll see you later. This video has been brought to you by Connect the Dots Online Math Tutoring. Before you leave, click on the like button and the subscribe button, and have a wonderful day.